Alright, let's look at a couple more examples from our notes packet from this week. We've already done example 3 here. We graphed it, but in case people didn't get it, let's just run over it one more time. So negative 4 is the x direction. So that means we're going to start at 0, 0, and we're going to go negative 4 diagonally, 1, 2, 3, 4. And then negative 6 is the y direction, which is side to side. So from where we ended up with the x, we go back 6. 1, 2, 3, 4, 5, 6. And then we go up 5. That's the z direction. So this is our point that we graphed. Alright, and then like we said before, this L is part of our rectangle, so we're going to continue out the back part of the rectangle here. And then since we went back 4, we're going to come out toward us 4. So we're going to go diagonally 4 from each corner. So 1, 2, 3, 4 this way. 1, 2, 3, 4 that way. And 1, 2, 3, 4 that way. Okay, and then we connect these corners. And we can shade in the top here. Okay, I think we went over most of the points on this. Let's just kind of make sure we're all on the same page here. So this point here is 0, 0, 0. This one we went back 4, so that's negative 4 in the x direction. So negative 4, 0, 0. This point we went straight over 6. That's in the y direction, so it would be 0, negative 6, 0 for that point. And then a couple more. If we go this point here, that's back 4 and up 5, so it'd be negative 4 for the x, 0 for the y, and then 5 for the z. And then we'll do one more at this point back here. There's a couple more. I mean, you should try to do these on your own. But this point back here, we went up 5, back 6, or left 6, and then back 4. So it's negative 4 for the x, negative 6 for the y, and then 5 for the z. Okay, so we've got most of the vertices. It also asked us to find the surface area and volume and the length of a diagonal of this box. So let's do those in that order. We'll start with surface area. That was question 4 on your sheet. And if you recall, yesterday we looked at the top, the bottom, the left, the right, and the front and the back. So the top and the bottom are the same. So if we just kind of figure out how big the top is, we'll be able to figure out the bottom as well. Oops. So the top is 6 across and 4 back. So that one's 6 by 4. Same with the bottom, 6 across and 4 back. The left and right, those are 5 tall and 4 back, so 5 by 4. And then the front and the back, the front is 6 across and 5 tall, so is the back. So front and back is 6 by 5. So the top and bottom are 6 by 4. 6 times 4, that's 24. The left and right are 5 by 4, that's 20. And the front and back, 6 times 5 is 30. So the total surface area is 24 plus 24, because there's the top and the bottom. So it'll be 24 plus 24. The left and right are 20 and 20 each. Oops, that's supposed to be a 20. Let's fix that. And then the front and back are 30 and 30. So we add this up, we end up with 148 in units squared. Okay, so that's the surface area. The volume is length times width times height. The length of this is 4, the width is 6, and the height is 5. So it's 4 times 6 times 5. And if you put them in a different order, it really doesn't matter. If you did 4 times 5 times 6, that would be the same thing. So 4 times 6 times 5 is 120. So 120 units cubed. Okay, and then the last part of this one, number 6, it asks you to find the diagonal. And if you recall what we did yesterday, the diagonal, we do a squared plus b squared plus c squared equals d squared. So A, B, and C are 4, 6, and 5. They're just the length, width, and height of the box. So it would be 4 squared plus 6 squared plus 5 squared equals d squared. So 4 squared is 16, 6 squared is 36, and 5 squared is 25. Scroll down a little bit here. So 16 plus 36, that's 52, plus 25 is 77. I'm just going to double check with my calculator down here. $16 plus 36 plus 25. Yep. And then since we got d squared equals 77, we square root that. And we get about 8.78. So the diagonal is about 8.78 inches or units long. Okay. So if you haven't done example 4 already, do that one on your own. But let's move on to the next page then, for examples 5, 6, 7, and 8. What it asks you to do is plot these 2 points, and then find the distance between the points, and find the midpoint. So let's start by plotting these two. So we'll start with -2, 5, -3. So -2, and then 5, then -3. That's going to be our first point. We'll call that C. And then D, I'll switch colors and use blue to do D. So D would be 6, negative 3, 7. So 1, 2, 3, 4, 5, 6. Negative 3 and 7. That's our D. That's a D, not a P. Okay, so what we need to do is figure out the distance between these two points here. And so to do that, we need to figure out how far apart are their x's. And so the x's on the first one we went back 2, and on the second one we went out 6. So altogether, that is 8 apart for the x's. And then for the y's, here we went over 5. And then on the blue one we went back 3. So 5 plus 3, that's also 8. So I'm going to put a little, this is called delta. The difference in the x's was 8. The difference in the y's we said was also 8 because it was 3 this way and 5 the other way. And then the difference in the z's, well, we went up 7 for this one. And then on this one we went down 3. So if we went up 7 and down 3, that difference is 10. Because one way we're going up, the other way we're going down. So to figure out from positive 7 to negative 3, we'd go 7 and then 3 more, which is 10. Okay, so we've got the 2 points plotted, C and D. We don't have to draw the box or anything like that. And then it says find the distance between the 2 points. So for part B on here, I'll extend this out a little bit. For part B, we're going to use a squared plus b squared plus c squared equals d squared. And a, b, and c are the difference in the x, the y, and the z. So it's going to be 8 squared plus 8 squared plus 10 squared equals d squared. So 8 squared is 64. It's also 64 there, and it's 100 here. So 64 plus 100 is 228. And you could always use a calculator just to verify that. And then we're going to square root 228. So square root 228. And we get about 15.1. So the diagonal on this one is about 15.1. Or that's the distance between C and D. Okay. So part B we've got down. We plotted the 2 points. Check that off. We found the distance. Check. And then the coordinates of the midpoint. So the midpoint is the point that's right smack dab in the middle of D and C. So if we connected D to C here, I'll do my best to draw a dotted line between the two of them. The middle of it's going to be somewhere right in here. Now it looks like it's around 0, 0, 0, but it's not. What we need to do is we need to figure out, well, what is the average of these two? What's the average of these two? And then what's the average of these two? So for the midpoint, we're going to take both of these, -2, 5, -3, and 6, -3, and 7. We're going to average them out. So let's start with the x's. They're -2 and 6. I'll switch up colors here. So for the x, we do -2 plus 6 divided by 2. We're finding the average, and if we have two numbers and you have the average, you add them up and divide it by 2. So -2 plus 6, that's 4, divided by 2 is 2. So the x is going to be 2. The y's are 5 and -3. So we'll add those up and divide it by 2. So 5 plus -3, that's 2. 2 divided by 2 is 1. And then lastly, for z, let's go up here and take a peek at it. Z is -3 and 7. So we'd add those two up and divide it by 2. That's 4 divided by 2 is 2. So our midpoint is 2, 1, 2. That is our midpoint. So let me put a box around that. That's our answer here. Okay, so I think you've got enough information to do the homework for today. You can grab that from the teacher. They should have the homework sheet for you. And then you should be able to finish up all the notes that we've taken so far. So that's your task for the rest of the period. Have a wonderful day. I'll see you guys tomorrow.